Welcome back, and in this lesson I'll be talking about service control policies, or SCPs. Now SCPs are a feature of AWS Organizations which can be used to restrict AWS accounts. They're an essential feature to understand if you're involved in the design and implementation of larger AWS platforms. Now we've got a lot to cover, so let's jump in and get started. At this point, this is what our AWS account setup looks like. We've created an organization for Animals for Life, and inside it we have the general account, which from now on I'll be referring to as the management account, and then two member accounts, so production, which we'll call prod, and development, which we'll be calling dev. All of these AWS accounts are within the root container of the organization. That's to say they aren't inside any organizational units. In the next demo lesson, we're going to be adding organizational units, one for production and one for development, and we'll be putting the member accounts inside their respective organizational units. Now let's talk about service control policies. The concept of a service control policy is simple enough. It's a policy document, so a JSON document, and these service control policies can be attached to the organization as a whole by attaching them to the root container, or they can be attached to one or more organizational units. And lastly, they can even be attached to individual AWS accounts. Service control policies inherit down the organization tree. So this means if they're attached to the organization as a whole, so the root container of the organization, then they affect all of the accounts inside the organization. If they're attached to an organizational unit, then they impact all accounts directly inside that organizational unit, as well as all accounts within OUs inside that organizational unit. So if you have nested organizational units, then by attaching them to one OU, they affect that OU and everything below it. If you attach service control policies to one or more accounts, then they just directly affect those accounts that they're attached to. Now I mentioned in an earlier lesson that the management account of an organization is special. One of the reasons it's special is that even if the management account has service control policies attached, either directly via an organizational unit or on the root container of the organization itself, then the management account is never affected by service control policies. Now this can be both beneficial and it can be a limitation, but as a minimum you need to be aware of it. As a security practice, because the management account can't be restricted using service control policies, then generally in production I avoid using the management account for any AWS resources. It's the only AWS account within AWS Organizations which can't be restricted using service control policies. As a takeaway, just remember that the management account is special and it's unaffected by any service control policies which are attached to that account either directly or indirectly. Now, service control policies are account permissions boundaries, and what I mean by that is they limit what the AWS account can do, including the account root user within that account. Now, I talked earlier in the course about how you can't restrict an account root user, and that is true. You can't directly restrict what the account root user of an AWS account can do. The account root user always has full permissions over that entire AWS account. But with a service control policy, you're actually restricting what the account itself can do, specifically any identities within that account. And so you're indirectly restricting the account root user because you're reducing the allowed permissions on the account. You're also reducing what the effective permissions on the account root user are. So this is a really fine detail to understand. You can never restrict the account root user. It will always have 100% access to the account, but if you restrict the account, then in effect you're also restricting the account root user. Now you might apply a service control policy to prevent any usage of that account outside a known region, for example, US East 1. You might also apply a service control policy which only allows a certain size of EC2 instance to be used within the account. Service control policies are a really powerful feature for any larger, more complex AWS deployments. The really critical thing, though, to understand about service control policies is they don't grant any permissions. Service control policies are just a boundary. They define the limit of what is and isn't allowed within the account, but they don't grant permissions. You still need to give identities within that AWS account permissions to AWS resources, but any SCPs will limit the permissions that can be assigned to individual identities. Now, you can use service control policies in two ways. You can block by default and allow certain services, which is an allow list, or you can allow by default and block access to certain services, which is a deny list. Now, the default is a deny list. When you enable SCPs on your organization, AWS apply a default policy which is called full AWS access, and this is applied to the organization and all OUs within that organization. This policy means that in the default implementation, service control policies have no effect since nothing is restricted. As a reminder, service control policies don't grant permissions, but when SCPs are enabled, there is an implicit default deny, just like IAM policies. If you had no initial allow, then everything would be denied. So the default is this full access policy, which essentially means no restrictions. It has the effect of making SCPs a deny list architecture. So you need to add any restrictions that you want to any AWS accounts within the organization. An example is that you could add another policy such as this one called deny S3, and this adds a deny policy for the entire S3 set of API operations, effectively denying S3. You need to remember that SCPs don't actually grant any access rights, but they establish which permissions can be granted in an account. So the same priority rules apply: deny, allow, deny. Anything explicitly allowed in an SCP is a service which can have access granted to identities within that account, unless there's an explicit deny within an SCP. Then a service cannot be granted. Explicit deny always wins, and in the absence of either, if we didn't have this full AWS access policy in place, then there would be an implicit deny which blocks access to everything. Now, the benefit to using deny lists is that because your foundation is to allow wildcard access, so all actions on all resources, as AWS extends the amounts of products and services which are available inside the platform, this allow list constantly expands to cover those services. So it's fairly low admin overhead. You simply need to add any services which you want to deny access to via an explicit deny. Now, in certain situations, you might need to be more conscious about usage in your accounts, and that's where you would use allow lists. To implement allow lists, it's a two-part architecture. One part of it is to remove the AWS full access policy, and this means that only the implicit default deny is in place and active, and then you would need to add any services which you want to allow into a new policy. In this case, S3 and EC2. So in this architecture, we wouldn't have this full AWS access. We would be explicitly allowing S3 and EC2 access. So no matter what identity permissions identities in this account are provided with, they would only ever be allowed to access S3 and EC2. Now, this is more secure because you have to explicitly say which services can be allowed access for users in those accounts. But it's much easier to make a mistake and block access to services which you didn't intend to. It's also much more admin overhead because you have to add services as your business requirements dictate. You can't simply have access to everything and deny services you don't want access to. With this type of architecture, you have to explicitly add each and every service which you want identities within the account to be able to access. Generally, I would normally suggest using a deny list architecture because, simply put, it's much lower admin overhead. Now, before we go into a demo, I want to visually show you how SCPs affect permissions. This is visually how SCPs impact permissions within an AWS account. In the left orange circle, this represents the different services that have been granted access to identities in an account using identity policies. On the right in red, this represents which services an SCP allows access to. So the SCP states that the three services in the middle and the service on the right are allowed access as far as the SCP is concerned, and the identity policies which are applied to identities within the account, so the orange circle on the left, grant access to 4 different services, the 3 in the middle and the 1 on the left. Now, only permissions which are allowed within identity policies in the account and are allowed by a service control policy are actually active. On the right, this access permission has no effect because while it's allowed within an SCP doesn't grant access to anything. It just controls what can and can't be allowed by identity policies within that account. Because no identity policy allows access to this resource, then it has no effect. On the left, this particular access permission is allowed within an identity policy, but it's not effectively allowed because it's not allowed within an SCP. So only things which are in both the identity policy and an SCP are actually allowed. In this case, this particular access permission on the left has no effect because it's not within a service control policy, so it's denied. Now, at an associate level, this is what you need to know for the exam. It's just simply understanding that your effective permissions for identities within an account are the overlap between any identity policies and any applicable SCPs. Now, this is going to make more sense if you experience it with a demo. So this is what we're going to do next. Now that you've set up the AWS organization for the Animals for Life business, it's time to put some of this into action. So I'm going to finish this lesson here, and then in the next lesson, which is a demo, we're going to continue with the practical part of implementing SCPs. So go ahead and complete this video, and when you're ready, I'll look forward to you joining me in the next.